Welcome to Fibre Tech again. Today is a bit of a basket case repair video. So this is a pressure washer that's been sitting around for a while around my mother's house. She bought it quite a while ago, hasn't done much with it. There's, valves been added to it, patchwork all over the place. The bolts are loose enough, the pump bolts I should say, are loose enough to just loosen with your hands. You can take it out with your hands. So today is just a bit of coming along as I fix this thing up and get it running. So without further ado, I'll bring you in closer and we can have a look at some of the issues for today's fix-its. So now, yes, I'm holding the camera by hand, but this should allow us to see what's happening. So as you can see, this valve here is not original, but this makes it a lot easier to operate because that actually allows you to turn off the water inlet coming into the pump. This pressure relief valve has also been fiddled with, and it doesn't actually really work. It just sort of stays on permanently. I know it's not safe, but anyway. This used to be a soap inlet, which it's definitely not anymore. You can see that that's had a bit of modification to it. There's a bolt now in that because the venturi on the output has been drilled out, which I may be able to show or may not be able to show, but there's actually a hole in there to do with actually driving it. So there's actually a little tiny hole in there that's been drilled out, which now instead of sucking in from this valve or this tube, it now blows water out, hence why it has now got a bolt in it. So yeah, these are the pump bolts. Oops. These are the pump bolts I was talking about. There's of course 4 of them, and they're actually fairly loose. So we're going to Loctite those in. I have no idea what the condition of the oil is inside this pump housing. I'm going to use a little dipstick and have a look at that. So, a few issues. 4 mount bolts need to be redone. I need to refit this so it's properly and also Loctited in place. I need to check this out. I need to check this out to make sure it's actually pressure regulating. I need to check the oil. But yeah, that's about it. So next will be a theory of operation of how these pumps work for those who don't know. So if we have a look at the front of this, you may notice there's 6 Allen keys. 1, 2, 3, 4, 5, 6 Allen key bolts. That refers to the 6 check valves, or one-way valves that are inside a motor, inside a pump like this. So essentially, there's 3 cylinders, which are these 3 cylinders here. Essentially, first, second, and third. This is not what's known as a positive displacement pump. This is very similar to a water pump that you'd have in your engine, which is a centrifugal pump, except this is a multi-stage piston pump. Essentially, the water comes in here at mains water pressure, comes into the first cylinder, the piston drives that, compresses it, and pushes that water into the second cylinder, basically essentially doubling or tripling its pressure. Then it comes in to this one, does another tripling of the pressure out to this one, another tripling the pressure out to here, out to this outlet, which goes off to the hose, which then goes off to the nozzle and the handle, which has its own issues. This here, for those wondering, is a overpressure relief valve. Essentially, this white dot is a specialized piece of plastic. That specialized piece of plastic is used so if this pressure, or the pressure behind this, gets too high, it blows this out. It basically just disintegrates the plastic and lets the pressure out of the system. That hasn't happened on this one yet, although I'm highly expecting it will eventually. Other things that have been done on this motor is I'll turn this around, is the fuel tank is a bit rusty in this one. It still works fine, it's just a bit rusty, so you gotta make sure you don't keep fuel in it. The carburetor has also been completely reserviced, which is on this side of the engine. That's been completely redone because its needle was blocked as well. So I'm going to stop the video here, I'm going to reset up, I'm going to take off the bolts, I'm going to check the oil in the pump, I'm going to check a whole bunch of other stuff, and we'll just bring you along and I'll chat through what I'm doing as I'm doing it. Right, so one of the first things I'm going to do is, this is why I have to pull the thing apart in the first place, is this little nozzle. Try to get it in focus. Is blocked clean through. That's meant to be a slit. It's not a slit right now. It is full of, I have no goddamn idea. So, I'm going to use whatever tools I have in the shop to unclog this little nozzle. I'm pretty sure this is part of some of the Loctite or seals or something of the internals of the system. But exactly why it clogged up, I'm still kind of debating which of the things inside that pump assembly down there clogged up. Because this is very, very, very clogged. Point where I may actually have to get out a drill bit to fix this. So what I'll show you is what I mean without, you know, completely blowing out the camera. So if we have a look, you may be able to see the fact that that is not really a slit anymore. As also demonstrated by the fact if I put a light behind it, no light comes through a nozzle. If I grab one of the other nozzles, other nozzles for this system and we shine a light through it, you can see that the pinhole comes through. We don't get that with this 40-degree nozzle. I believe it's a 40-degree nozzle. When we shine a light through the back of it, it's completely blocked. So that is, of course, an issue, and that's why we had so many issues with this pump basically being a non-starter. We did a lot of work with it, and then it decided to basically clog itself up and then say, nope, I'm not doing any more work. So that's what I have to deal with today as we go through. So, I'm seriously concerned about how blocked up that is. I wonder if I've got a drill bit small enough. And what's the bet my drill bits are next door? Of course they are. Let's see if we're 1.5 is. Nope. I'm gonna have to grab some more tools. Wow, that is really well clogged up. Break out a knife to try to see if I can't chip out some of this. It is really well clogged. So I'll come back when I have this clean and we'll show what it actually should look like. Okay, we're back after I have cleaned out the nozzle. So it may not look much different from that way, but when I now shine a light through it, we can now see that pinhole. It's a very nice, quick, simple test to tell if the pressure washers are blocked. Pressure washer nozzles are blocked. Because 99% of the time, the reason why you're not getting enough flow through one of these Gerbers is because the nozzle's blocked. So that's job one for today. Done. Now I'm going to take off the pump, big black thing down there, and I'll bring that up onto the bench, and then we'll have a look at it from there. Okay. So I'll put this away, and we can just go straight to that. Now, Allen keys. And now all pumps are going to be a little bit different as to the way that they attach and work. This one here actually has about 3 different styles of motor mounts to them. So you just got to sort of take a bit of a, I was going to say, scientific approach to pulling these things apart, because they can be a bit of a minefield, as it were. Again, this is sort of an off-brand of another off-brand, so it's a very, itself in place. So it's a very different sort of kettle of fish to, you know, a genuine gurney. If you found a disassembly guide for a petrol-powered gurney, well, that's going to be completely different to this, because this is an off-brand of another off-brand. So those disassembly instructions may mean nothing. So bear that in mind if you've got one of these sort of weirder brand ones. Just, you know, take it nice and slow. take out 1 or 2 bolts, see how that affects things. Take out another 2 bolts, see how what that pulls apart. Because it can take a bit to get these things apart. They're not really designed to come apart. So just bear that in mind when you are actually doing stuff with them, that you can have those sorts of issues. It seems like since last time I did this, which would have been yesterday, I would have looked at this, these bolts have actually tightened themselves up a little bit. I think that because the engine block's cooled down, so I didn't need the Allen key to actually remove them. For those wondering, I will be using some red Loctite to refasten these screws in once I'm done with it. But I have to get this pump off first to see how mangled it is, which means I have to take out that one. Vice grips to the rescue. I know there's probably a plumber out there cringing at me for using vice grips on brass pipe, but I kind of got no other option. Knowing how hard this sort of stuff is always put on. I don't have shifters or spanners big enough to actually clamp onto this anyway. So, oops, still got some water in it. Come off. Nope. Boop 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 boop. Boop 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 boop. Holy cow. That's done really tight. So now that that valve is off, so this is just a standard gate valve that's been used to control the main input, so you'd have to rush back and forth. So yeah, now that should, yeah, there we go. Ooh, that's a dirty system. So what we'll do is we will swing ourselves over the bench a bit more. So this is that 3-stage pump again I was talking about. So you can see how inlet, outlet, 3 pistons, 6 check valves. There's a check valve on the inlet of each one. There's a check valve on the outlet of each one. I think these are actually the inlet check valves, and there's the outlet check valves of each of those cylinders. Well, they sort of alternate. This is the pressure relief. So this is actually how you control how much pressure is coming out of this side. This is essentially a spring detent. So the high pressure acts on a piston. Which is preloaded by another spring, and when the pressure of this pump exceeds that pressure that's acting on the bottom of that ball T10 or that detent, it pushes the spring away and allows that high pressure water to return back to the inlet, so it doesn't come out the outlet. Just the way that this one works. Again, each of these is going to be a little bit different. So. So I'm just going to clamp this thing up in my ghetto vise because I got no other option. Just enough to hold it in place. Just enough to hold it in place whilst I'm working on it, so I don't have to worry about it falling to the ground and breaking, because you know this is a $1,600 piece of kit. And I'm about to check the engine oil to see the pump oil to see how mangled or non-existent this one is, because I have no idea. Here it is. There's the little seal and all. Let's get ourselves a clean dipstick so I can see how mangled this oil is. If I had a dipstick lying around, that would be good enough to use. Okay, let's see if I can't find something. Yeah, nah, that'll work. A bit of baling twine will work. also got to check the motor oil on that one too. Well, there's no chunks in it, which is a good start. It's a little bit low. Yeah. Unfortunately, I don't have any oil to actually put back into this, so I've got no way of actually refilling this. All I know is it does have the oil, which is a good start. It doesn't look too bad. Yeah, it's pretty dark, but that's expected for hydraulic pumps, that sort of oil. But I'm happy with that. If I had the oil, I would probably top her up, but I don't. So it will have to do. I've got a spanner the right size sitting around. Nope, I need 11. That is 11. I need the 10. There it is. Well, a lot of stuff happened then. Sorry about that. Whoops. Just a shovel, a broom, and a few other things moving in the workshop. Standard thoroughfare for around here, of course. Yeah, there it goes. So we know that bit's okay. Well, next thing I'm going to do is I'm going to take off some of these check valves and have a look at what they look like internally to see if they're completely mangled or not. Also, let me have a look at the pump cylinders as well. Check valve's good. So these are just brass plugs. You probably can't see them, but these are just brass end plugs. Nothing too fancy, nothing too crazy. But there's actually check valves in here. Each one of these contains a check valve or a one-way valve, so it only allows pressure in one direction. So we'll take one of these off at the front. Yeah, they look okay. Seals aren't completely melted, so I'm happy with that. There goes that. Yeah, I know this is actually a plank clamp that I'm using as a bench vise. I know, but I got no real options, so hence it becomes this sort of stuff. So next to come off is going to be this outlet pipe work. I've got to recenter this to be vertical, and I got a few other things to do as well. So again, that comes with vice strips because I got no other options, people. Okay. This probably actually shows better as well what I was talking about with the drilled out hole. If I now put the light behind it, you can see that that hole in there is huge. Like, 3 times, 4 times bigger than it should be. Okay? So that hole in there is about 3 or 4 millimeters. It should only be about 1/2 millimeter or so in actual size. The reason for that is this acts as what's called a venturi. So water pressure comes in. So water pressure comes in here, goes through here to this way. That little hole acts as another gallery, which I can show you. There's actually a gallery through the top of this, a little hole in the top. When that hole in the top does something, what it does, essentially speaking, is it gives suction. It sucks. So water's coming this way, okay? And that little gallery on top, it sucks in because of the venturi. It's essentially a pressure actuated vacuum. So by the difference of pressure between here and here, by using that small hole, you can create a vacuum, and that's what this is meant to be for. This is actually meant to go off to a soap bottle. The problem with that is that that's been drilled out to a size way bigger than it should have been, that little hole in the middle. Therefore, this doesn't act as a suction point, it acts as a spout. It actually shoots water out. So that's an issue that I can't fix without completely remachining this entire fitting to the correct size. So that's why there is a screw in this. However, the base fitting in here is actually a 1/8 inch BSP, so my plan is to actually put a pressure gauge on this, a high pressure gauge on this. Eventually, that will be my plan, so I can monitor what the water pressure actually is coming out of this pump. So therefore, we can actually use this pressure regulator and actually regulate some pressure. So, with all that explained, we will screw this back on and actually make this sit in the right position. So therefore, it can actually be used later. Oh, but before I do that, because this is a user serviceable part, or user accessible part, because the hose threads onto here, I am going to Loctite the this thread on to make sure that we don't have the issue of it slipping on us, because that's another thing that happened when it overheated, or I should say it got blocked, is that it actually unthreaded this bolt, this whole fitting vibrated off. And that smells like raspberries. So what we're going to do is I'm going to thread that on nice and tight. So therefore it sits and is locked in place. So yeah, that's that one in place. The next thing I've got to do is, as you may have noticed when I was working with it, this bit always span around, this tap always span around. That's because the physical length of this threaded section is too long. And because that's too long, what it does is it doesn't actually fully press up against this hex nut here. And when it does that, it causes a whole bunch of issues. So when it does not, I should say, properly mount up hard against this object, it just spins loose because there's pressure there, but it's not enough pressure to actually lock this fastener in place. So what I'm going to do is I'm going to grab a file and I'm going to turn off the camera. I am going to file this down so it actually meets up, and then we'll come back when I'm done. So, realizing that I have quite a bit of material to remove from this fitting before it will actually properly fit into this fitting, I'm breaking out a power tool. This is just a ordinary orbital sander. So what I'm going to do is, yes, I'm going to issue a headphone warning because this thing is not exactly the most quiet thing. And if I do find out a way of muting this thing or this segment in post, I will. Otherwise, I'm just going to have to wing it. All right. So I'm going to have to get some eyes and some ear protection from next door. So now I'm all geared up. We are going to turn this puppy on and away we go. I keep forgetting this one's been used for plaster sanding, so the air filter is all full of plaster dust. Well, let's see if this works now. Test fit time. Yeah, so this is the issue we're talking about, is once it's actually fully fitted on there, it still woggles loose, and this becomes a leaking point right behind this valve. So even this side is all waterproof. This bit here doesn't become waterproof because of lack of compression. So I have to keep filing it down until I have a fit that works. Alright. I don't think that's working very well. It's only taking off, a few thousandths at a time, but it's still faster than me doing it by hand. Ooh, that's some seriously dirty glasses. Alright. Headphone warning! Just casually remounting it so I don't actually have to hold onto the thing as much. It should be a little bit more stable. Alright, headphones again. Okay, that's not working. I've got to a point now where it's actually a little bit too short. So we have to find some of these washers that are in here in the next shed, and probably come back once I've figured all this out. A single washer, isn't it? You need to work out these washers. Alright, so I need a few more of these 3/4 inch washers. Let's hope one is actually enough. And it's not even the right size. God damn it! Yeah, it's not even the right size. Yeah, it's too big. Alright. Right. Let's try some O-rings. That is metric. This one is imperial. Before I do that, I'll try this. Do 3/4 inch. I don't know if I have anything 3/4 inch. I have 3/4 inch OD and ID. So 3/32 of a section. So we're talking probably R14. 14, 16, 15, 14. Haha, R14 is the money shot. So that is a 13/16 ID with a 3/32 inch fitting. So let's see how many R14s I need to get the thing to work. 1. Right. So now that doesn't wobble, so that now is held fast, which is what you want. That also means that now you have no leaks, or less leaks hopefully. Right, I think we're ready to put this back on the motor once I reposition the camera. Alrighty then. Now, to get this pump back on. It's a very dirty keyway. Of course, the way this fits, I need to actually take off the thing we just put on. Keyway's not lining up. Keyway is not lining up. There we go. There we go. Okay, keyway back on. Inlet valve. So inlet valve now coming back on. Going back on, I should say. There we go. Now we've got to screw some stuff in. And of course Loctite everything down, because this is what came off last time. Now I'm not doing these up too tight so I can have some remote possibility of getting this pump off ever again. For those wondering how much Loctite I'm putting on, I'm only covering 2 threads with Loctite. So essentially 2 threads in, and then it's the next 2 threads. So if you're looking at the bolt from side on, you should see 2 clear threads and then 2 dabbled with the lock thread on it. That's just my preference. How much you put on is completely up to personal preference. Although you don't want to put too much on or else it leaks everywhere. That is a very sticky mess to take care of. Number 3 in. Sorry, number 2 in. I'm doing number 3 now. It's a bit warm out in this shed. I live in Australia and it's summer here. Wow. Almost. I think today is about 30 degrees in this shed, give or take, so not exactly the coldest thing in the world. There we go, 2 and 2 again. Alright, last one. Then and take it outside and start her up, and hopefully it pumps water. There we go. Right, I'm going to stop the camera now. I'm going to take this thing outside. I'm going to see if it runs. Well, I think that worked. Still back up and running again. That's about all to say. Thank you for watching, and I'll catch you on the next one. See ya.